When connecting multiple sets of conductors to a power block, you are creating a tap. The conductors connecting from the power block to individual disconnects are tap conductors. According to the National Electrical Code, NEC, tap conductors must meet specific requirements. Firstly, ampacity. The ampacity of the tap conductors must be at least 1/3 of the ampacity of the main conductors. Secondly, length. The length of the tap conductors must not exceed 10 feet. Thirdly, protection. The tap conductors must be protected against overcurrent by a fuse or circuit breaker sized according to the ampacity of the tap conductors. NEC Article 240.21 requires that the tap conductors be installed in a manner that prevents overheating and mechanical damage. In a scenario involving 500 kcmil conductors feeding a power block within a wireway and tapping off to 3 individual 200 amp single-phase 240 volt disconnects using 4/0 conductors, several factors need consideration. The tap conductors, which are the 4/0 conductors in this instance, have an ampacity of 320 amps. This ampacity must be at least 1/3 of the ampacity of the main conductors, which are the 500 kcmil conductors. The ampacity of 500 kcmil copper is 675 amps according to NEC Table 310.16 for 75 degrees Celsius rated conductors, which is a common termination temperature rating. 1/3 of 675 amps is 225 amps. Since the 4/0 conductor has an ampacity of 320 amps, it satisfies the 1/3 rule. The length of the tap conductors is specified to be within 10 feet, which meets the NEC requirement for tap conductor length without overcurrent protection at the tap's origin. The NEC requires that tap conductors be protected against overcurrent. The overcurrent protection must be sized according to the ampacity of the tap conductors. In this case, the 4/0 conductors must be protected by a fuse or circuit breaker no larger than their ampacity. NEC Article 240.4 addresses protection of conductors. For example, if 75 degrees Celsius terminations are used, the allowable ampacity is 320 amps. Therefore, the overcurrent protection device should be no larger than 320 amps. Common practice is to use a 200 amp breaker since that is the load it is feeding. It is acceptable to connect the 4/0 tap conductors to the power block, provided they meet the ampacity, length, and protection requirements as specified in the NEC. Ensure that all connections are properly made and torqued to the manufacturer's specifications to prevent overheating and loose connections. Using a power block within a wireway is a common method for distributing power from a larger conductor to multiple smaller conductors. The wireway itself must be sized appropriately to accommodate the conductors and meet the full requirements of the NEC as specified in Article 376.22. The 10" by 10" by 6 foot wireway appears adequate, but a calculation should be performed to confirm. Wire fill calculations involve determining the cross-sectional area of the conductors and comparing it to the allowable fill area of the wireway. NEC Chapter 9, Table 4 and Table 5 provide dimensions and fill percentages for wireways. The connections within the wireway should be accessible and properly labeled for future maintenance and troubleshooting. It is important to ensure that the power block is appropriately rated for the voltage and current it will be carrying. The power block must be listed and labeled for its intended use, and it should be installed according to the manufacturer's instructions. Additionally, the wireway must be properly grounded and bonded to ensure a safe and reliable electrical system. Grounding and bonding requirements are outlined in NEC Article 250. These steps will help ensure that the installation is compliant with the NEC and that the electrical system operates safely and reliably.